What's going on, you guys? Welcome back to the channel. And today we've got kind of a fun one for you. We're going to learn to build the classic game Pong, the game that pretty much started modern video games. We're going to learn to recreate that in Python using Pygame. So we're going to try to move pretty quick and fit this whole game into one video here. So if you're unfamiliar with Python in general, I recommend you start with one of the very intro series that's on this channel. And if you like this and you want to see more content like this, be sure to leave a like and a subscribe to the channel. It helps me out a ton. And without any further ado, let's get right into it. So with any game in Python, if you're going to use Pygame, the first thing you're going to want to do is import Pygame. This should be pretty familiar. And then the second line is just pygame.init, so you're actually calling the pygame function and starting the whole module. And then really the next thing you're going to want to do is define your screen. You can't have a game without a screen, so that's going to be screen equals pygame.display.set mode, and then you define a size in pixels and put those inside of a square bracket. Okay, so now we've just created a screen that's going to be 300 by 300. You can play around with the settings if you want. I've made this before, making this video, and 300 by 300 works pretty good for Pong, but hey, you can do whatever you like. So then pygame.display.set caption, I like to do this second because you're just saying what you're going to call the game. So we will just call it Pong Reboot. That's pretty sweet. And then let's see. Something I do in every game is I create a timer, because if you watched the first Pygame tutorial series on this channel, I talked about this in more depth. But essentially, your game will run or could be limited by the hardware that you're playing it on unless you define an FPS to play it at, like a frame rate. And so if you want to do something where it's running at a fixed FPS, like 60 frames is pretty common, then you need to go ahead and create yourself a timer early in your code, and then also just create a frame rate variable, 60, 30, whatever you want it to be. And we'll go ahead and use that pretty soon. So then inside your code, you create your actual like game loop, which is going to be create a variable. I usually use running, almost always use running. And then while running is true, or you can just say while running if you're using a Boolean variable. So while running is true or equal to 1 or whatever you want to call it, then we're going to go ahead and do timer.tick at frame rate. And so Python now knows that it's going to run at that frame rate. That's how many times it's going to run per second. That's the built-in clock function. So that's pretty sweet. This is our main game loop. And then you have to create an event to get out of the loop, right? Because right now this looks like an infinite loop. There's no way for running to ever go false. So you create the event handler, which is going to start with for event in pygame.event.get. So that's a generic Pygame function for grabbing any keystroke, any click, any movement of the mouse. That's all going to be handled in the event handler here. But then the first one you just want to make is if event.type is equal to, and we will use the Pygame built-in quit, because every time it draws a screen, there's a small red X in the top right corner, and that's the quit button. And so if they click that, then we are going to set running equal to false. And then that's all we're going to put in the event for now, in the event handler. And then outside the event handler, let's go ahead and put in, excuse me, pygame.display.flip and pygame.quit, and that's just kind of last stages. The flip is how you draw everything onto the screen, but let's go ahead and draw a background first. So just to have something, let's do screen.fill, and let's put 0, 0, 0 in there. So that's an RGB value. And let's just see, that might be all we have to do just to get a screen to pop up. Fill invalid rect style object. Let's take a look here. Fill. It looked like it worked. This might need to be in another set of parentheses. I don't know. It's just an RGB value. That looks okay. All right, I'm not sure why we needed the second set of parentheses, but we did, so put them in there. The reason that took me a sec, I usually like to define some colors up top so that I can use those throughout and just call them black, white, purple, whatever. So I'm gonna make those now, and I recommend typically when you're creating a game, build yourself a library of colors you want to use, create a font. That's what I'll do next here. But then anytime you need a color, rather than RGBing and trying to play around with variables, you have a library. And so if you really want something to be a specific color, then just play around with the RGB values, but play around with them in your variable definitions up here. Okay, so we drew the screen, and that's pretty sweet. Why don't we go ahead and for the next thing, let's draw the player and the like computerized right paddle. So we'll have the player on the left and the computer on the right for this game. All right, so let's go ahead right under where we did screen.fill, and let's create a rectangle that we'll call the player. And the player's location is going to be equal to pygame.draw.rect, and then we're gonna put it on the screen. We want it to be a white rectangle, and now we give it the 4 arguments needed for a Pygame rectangle. So this is gonna be, let's make it 5 wide, and then let's make the height, or I'm sorry, we're giving it X and Y coordinates first. So because in the game, what you're actually controlling when you move up and down is your Y coordinate, we're gonna create a new variable called player Y, and that's what we'll control. But then for the size of the rectangle, let's go ahead and make it 10 and 40. So you can play around with this after you draw it onto the screen and kind of figure out what works for you, and if you want to change it. I'm gonna create a little section here that I'm gonna call game variables. And so we need player Y. And let's go ahead and start with that equal to 130. Okay. So if I just go ahead and run this, you can see our character. Yeah, so I think that looks decent for a paddle, kind of retro, which is really what we're going for anyways. We're just trying to create a 1-for-1 of Pong. We don't need to make it super cool or advanced. Let's just get it working first. So second thing to do will be draw the computer paddle. You could make this 2-player. I don't have the mental capacity to play both of these on a tutorial at the same time, but you could make one, for example, that uses Q and A or W and S to go up and down, and the other one uses the arrow keys, and 2 people could sit at one laptop and play the game. But for now, I'm going to make it a computerized opponent. Plus, that will give everybody a little bit of practice drawing creating code as kind of an AI to play against, which is great practice as well to think about how a computer would handle the situation. And then, so instead of 5, we want to put this on the other side of the screen. So it's going to be at 285, right? Because it's 10 wide and we want it to be 5 away from the right, just like the other one. Okay, so when we run it, we have player on the left and computer on the right, and it's starting to kind of look like Pong. So obviously one piece that's missing, right, is the ball, which you could make it a circle, definitely, if you want. That's more like an actual ball, but since I'm going for classic Pong, I'm going to make it a real little rectangle, because that is what the first Pong game looked like. It was just a little pixel, or a few pixels, but you get it. You get it. Okay, so for this ball, we're going to draw it onto the screen again, and let's go ahead and make it white, just like the player and everything else. And I'm just in the game white. I don't know what color the player is. That's not important. Okay, so sorry, bad joke. Now let's go ahead, and the ball is actually going to be moving in the X and the Y direction, right? So let's make those variables, and just to start, let's make it 10 and 10. I think that'll be a good size, but if that looks too big or something, we can change it later. But okay, so now we need to create the ball X, and we'll put them pretty much dead in the center of the screen. So that'll be 145, since this is referring to their coordinates in the top left as you look at the object, and they're 10 by 10. So if we want them to be in the middle, we go 5 off. So there you can go. That's kind of how you want the game to look when it starts up, and that's what we've got here. So that's pretty cool. Let's keep going. Now, first thing I think we should do is handle the player movement, because it's not going to be too hard, and if we start coding the computers and the ball's movement and the player's powerless to do anything, then that just seems kind of weird to me. So let's go ahead and get into some more event handling now. And again, if you're following along, you can use whatever keys you want for up and down. You could use the up and down arrow keys. That would make a lot of sense. I've played a lot of the keyboard games that like A, S, D, W are your 4 directional controls, and I just like controlling the movement with my left hand. So I'm gonna go with W and S for up and down. Hopefully that makes sense. But event.key. But you can do it however you want. You can follow the same format, and then obviously you're just gonna, instead of here where I say if event.key equals pygame dot and then k underscore w, you would use k underscore up arrow, k underscore e, whatever you want. Just change the key out there. And if that is pressed, then we are going to want to move down. So I will make a variable that I'm going to call player y direction. Actually, I can just say player direction because we don't move in the x and the y. So I'll just say player direction is going to be equal to -1. And let's go ahead while we're here and let's do the opposite. And so you may be thinking like, hang on, if I hit W, I want that to be up. If I hit S, I want that to be down. Yes, that does make sense, except that it doesn't. Because Pygame starts from 0, 0 in the top left corner, and it goes higher numbers as you go down. So if you think about like your Y coordinate, if you want to move up, like go from the middle of the screen to the top, you're going to be at like 150 as your coordinate in the middle of the screen, but then 0 at the top. So move up, your direction is actually -1. Doesn't make a lot of sense, but hey, I didn't make it. Okay. So k underscore s is going to be player direction equal to 1. All right, and so now what we want to do is we want to make sure that we set the direction equal to 0 initially, because we do not want the player to just start out moving. And then we also want the direction to go back to 0 if they lift off the key. So let's see, if event type is equal to pygame dot, and now this is going to be key up. It's got to be 2 equal signs. Pygame dot key up. There we go. And if it equals k up, I'll go ahead and copy the kw and ks. That'll save us some typing time. And we're going to set equal to 0. And so if you think about this, if you hold W down or you hold S down, you want the direction to stay up or down the whole time. But as soon as you let go of that key, you want direction to go back to 0. So that's pretty cool. That'll do it. And then what we're going to do with that is actually, let's go ahead and update the player y variable, right? So player y plus equals. And now let's just say that the speed is 1 pixel per counter, which is going to be a total of 60 pixels per second. So let's say it's 1 times the player direction, right? So this is why we handled it that way. When direction is 0, your Y doesn't change at all. But then when the direction is negative, you go up towards the top of the screen. When your direction is positive, you go down towards the bottom of the screen. So let's run that. And yeah, so I'm holding W, and then when I let go, it stops, and I can go up and down, and what you'll see is like the paddle moves very slowly. So this is kind of the first way you can start thinking about potentially increasing or decreasing difficulty is with player speed. So I'm going to create a variable. I'm going to call it player speed, and I'm going to make it a little bit faster than 1. I'm going to make it, I think, 3. Now let's go 5. 3 is still a little boring. 5 is totally rad. Totally rad. Yeah, so I mean, I'm flying now. I mean, the idea of Pong is that like it starts off pretty slow, but as the game goes on, it can get more progressively difficult. And obviously, we can do a lot of things with it today that you couldn't have done back in '72 when it was made. But this is pretty sweet right here. We've got the up and down controls all set. So next thing I want to do is get the computer to track the ball, and then I want to get the ball moving. So let's see for that. I think we should make the computer's location the next thing that we update. So we're gonna have to create a new function and call it, I'll call it update AI because that sounds hardcore. But for this, we are going to be passing in the ball's Y coordinate and the computer's current Y coordinate, and then we're going to get the computer's Y coordinate back. So based on where the ball is, the computer's going to update where it is accordingly. So let's go ahead and create that function, and we called it update AI. Great name. I always use AI instead of computerized opponent because it makes me feel really advanced. Obviously you can probably tell from my code that I am not really advanced, but hey, works for me. Okay, so just so I don't forget what I'm passing back, I always kind of write the last line as well. So we are going to pass in ball Y, and let's go ahead and just in here, let's make a computer speed equal to, we'll give them 3. They can't be as fast as the player. As the player, you should always behave like you are the code's god, I guess. Okay, so computer speed of 3, and then what do we want to do? We want to check if the computer's Y coordinate, now you gotta think, it's 30 pixels wide, right? And really the way a computer would play this is to get into the optimal placement. So it doesn't just want the ball somewhere over the paddle, it wants it dead in the center, so there's room for error. So let's say if the computer plus 15, which again, think about the coordinate system going from 0 at the top to 300 at the bottom. So plus 15 is going to be in the middle of the paddle. And if that is greater than the ball's Y position, and we'll say plus 5, because again the ball is 10 wide. So what do we want to do if the computer midsection is farther down the screen than the ball's midsection is? We want to computer Y minus equal computer speed, right? Okay, and then we will say else computer, let's do elif, so elif computer Y plus 15 is less than ball underscore Y plus 5, and in that case that's saying that we need to go down the screen. So then we want computer Y plus equal to computer speed. Alrighty, and I actually think that's gonna handle it, but what you'll see is this isn't really gonna do much yet because the ball isn't moving. So I'm just gonna set the ball Y equal to 0. When I start this up, we should see the computer move to get to it. Bam. And then it freaks out because it's just bouncing around, but cool. So it appears that that works. Oops. It appears that that's working pretty good. But once we get the ball moving and bouncing, it should work a lot better. So let's go ahead and let's go ahead and move on to the ball. So I will create a function that I'm gonna call update ball. Update ball. I'm not completely sure yet what all it's gonna need passed in and what all it can do without. So let's just start writing it and we'll kind of flesh it out as we go. So update ball, and inside this function, it's going to basically take a look at let's separate into X movement and Y movement, and say if ball X direction. So we'll need to create a variable saying whether the X is right or left. So if it's equal to 1, that means that we're telling it to go right, and the X coordinate is less than, what do we want? Less than 290, I suppose. Let's see. We're going to start by drawing it to bounce off all the walls, and then we'll handle the collision with the paddles second. So if ball X direction is equal to 1 and the ball X coordinate is less than 290, then we are going to say ball X plus equal to, and let's do another variable called ball speed. So what I'm seeing here already is we're going to need to pass in ball X direction, ball Y direction, ball X coordinate, and ball Y coordinate, and then ball speed as well. So obviously we haven't made a lot of those variables yet. We're gonna create the function for updating it and moving it, and then we'll go ahead and kind of work backwards to create the variables. That's how I want to do it. There's obviously other ways to do it, so code it however you want. But let's just go ahead and say if the direction is 1 and the ball is less than 290, and then let's say if direction is -1 and X is greater than 0, then the ball is going to move to the left by the speed. Okay, so now we've got back and forth handled. Let's take care of up and down and say if ball Y direction, actually we also need to handle what happens when it hits those extremes. So my mistake. Let's do a if ball X direction is equal to 1. So we're telling it should go right, but now ball X is greater than or equal to that 290 marker. That means it's hit the right wall. So what we need to do is change ball X direction. Okay. So we're going to go ahead and multiply it by -1, and that's why I like using 1 and -1 rather than 0 and 1. You can actually update direction just by multiplying times -1, which is really handy. Like when you want it to collide with a paddle, you say, well, whatever direction you were moving, move in the opposite now. So that is pretty cool. And then for moving to the left, we're going to, you need an and. For moving to the left, we're going to add if ball X direction is equal to -1, and then it's gone all the way to the left, we'll flip it just the same. Okay, so now we need to sort of do the same thing for ball Y. Well, pretty much exactly the same thing for ball Y. So I am going to go ahead and copy this guy completely, and we're going to change some X's to Y's. And then I think we should handle the ball's speed in the Y direction different than the speed in the X direction. It's just my sense of things. You can make them one variable if you want. I think it'd be a little more fun to have X and Y update at slightly different times, so you get kind of slightly different paths of travel. Okay, So hopefully what we've done is we've just created a ball that bounces around in the extremities, in the off of all the walls. And what we want to do is just return ball X and ball Y for now, I think. We'll see, we might need to return more, but this should get the ball moving. Get the ball rolling. I know that was bad. Okay, so we need to go create 4 variables. Ball X direction, and we'll start it out moving to the right. Ball Y direction, we'll start it out moving down. And ball speed, we'll make it 2, and ball Y speed, which we'll make that 2 as well for now. Ball Y speed, but do we pass that in? Yep, okay. Alrighty, well, I'm just gonna run it and kind of let the code tell me what I did wrong. So it looks like we get into the bottom right and it tries to bounce back to the left once, but then immediately tries to go back to the right. So let's take a look here at our ball control. If it's going to the right and it's less than 290, just add it on. But then if it's going to the right and it's greater than or equal to 290 multiplied times -1, if it's -1, ball X minus equal ball speed, I don't know why it would be this, but I'm gonna just try. Oh, yes, I do. Okay. Stupid mistake. No surprise there. But we aren't actually able to update ball X direction and ball Y direction unless those exist outside of this function. So every time this gets called, it pulls these variables in independently, and we weren't returning them. So what we need to do is not just bring back ball X and ball Y, but also ball X direction and ball Y direction. And now it should bounce around all happy like. All right, sweet. We could try to follow it. It's bouncing straight into the corners, which is rad. So there you can see why I kind of like the idea of doing a different X and Y speed. It'll give you a little more interesting of a bounce pattern. But the other cool thing that you can see right now is the AI is tracking it and following it. So we haven't put in the code yet to handle bouncing off of the paddle and bouncing off of your paddle. But you can tell your computerized opponent is going to be tracking it pretty good. So let's actually do that next. That's going to be kind of the bulk of how Pong is played, right? It's actually the ball bounces off the paddles. And look, when they made Pong back in the day, they didn't have anything pre-built. PyGame kind of has the benefit of having a module to detect collision between different objects. So what we're going to do is in the event handler, next, kind of in that same area, we're going to check for collision. So let's get into that. And let's go ahead and create another. You could probably use this update ball function to do the same thing, but that function has already got a lot going on. So I think it would be wise to do a check collision separate, and we'll make 2 check collision player, and we'll do check collision AI, and these are going to look pretty similar, but for the sake of not having to pass in 10,000 parameters per not having to pass in 10,000 parameters per function. I think separating them out makes more sense. So we will do this. We will say player. I think we can just do player, and we might be able to just do ball. And then we will need ball X direction. And I think all we want, if there is collision, is we want to flip the ball X direction. So we can just ball X direction. So I think we can do it this way, where we pass in the ball, we pass in the computer here, and then we pass in the ball X direction. But let's go ahead and write the function, and I'm sure while we're writing the function that will probably direction. While we're writing the function, that'll tell us if we missed something. It always does. Okay, and we called this check collision with player. Just check collision player. Okay, and the order of the variables, let's go ahead and just steal these to be accurate. And we are returning ball X direction. So what I'm gonna do is if, and then this is a built-in Pygame function. It is if ball dot collide and then with player, okay? And then all I'm gonna do is say ball X direction and then times -1. I think that is all we have to do to handle bouncing off the paddle, because this collide rect is checking the rectangle of the object that you called, and then it's also checking the rectangle of the object that you put inside of the parentheses. So really, if it hits the player or it hits the computer, we just want it to go the opposite direction. So that might do it. Oh, I called it check collision AI. Yeah, that's hardcore. Haven't changed this name yet. Okay, so let's go ahead and run this, see if it bounces off the paddles. Okay, so we do return ball X direction, but it hits the right paddle and it just keeps bouncing into it. See, I don't know if this will fix it or not, but let's try combining these. Let's say check collisions, ball, player, AI, computer. Stupid. And let's go ahead and tweak our function to be check collisions. Pretty sure this isn't gonna be it, but gotta troubleshoot. Okay, so let's just say if it collides with the player that we want the direction to be equal to 1, and then if the ball collides with the computer, then we want the X direction to be equal to -1, bounce back to the left, and that will do it. All right, not super confident that that's gonna fix it, and apparently it did. Wow. All right, so look, we made it, guys. You can bounce off of the paddles. You can play against the computer. Like I said, you could set up the exact same controls for S and W for like up and down arrow, and then they could control the right guy if you wanted to. But right now, this is the basics of Pong working. And now I'm just gonna kind of add a few more things that I think make the game a little bit more fun. But right here, you just created, you know, the essence of Pong. So what I want to do next, before patting myself on the back too much, I want to get rid of the fact that it can just bounce off the left and right walls. I want to make that game over. So I'm going to start that process by creating a variable that I will call game over, and it's going to be equal to false right when the game starts. And we're going to create a new function that will call once per game loop, and I'm going to call it check game over. Okay, and we're gonna get the game over variable back from there. So game over is gonna be equal to check game over, and what we're gonna do is all we're gonna pass in is ball X. We don't need anything else because all we're gonna do is check if the game has gotten all the way to the left or not. And then let's go to where the ball updates, right? That is update ball, this function, and we'll say if game over is false or if not game over. Okay, so that should make sense. Now we're saying the ball is only going to update if game over is not true, and let's go ahead and take care of the code that's actually going to enter a game over scenario. So we called that function check game over, and we're passing in ball X, and I think we need to pass in game over as well, actually, because the current status of that is going to make a big difference. All right, and what we will say is if ball X is equal to 0, which is when it hits the left wall, or, and actually let's say less than or equal to, because if it's jumping around by multiple pixels, it's just better to catch it this way. So if it's less than or equal to 0, or ball X is greater than or equal to 290, because it's 10 pixels wide, so that's when it hits the right wall, we will say game over is equal to true. And let's go ahead and add another condition here and say and game over is equal to false. There's no reason to run this code if game over is true. So then we will return game over, and I think that will handle that. So let's go ahead and see. I'm gonna let it hit the left wall here real quick, and you can see the ball stops moving. Let's go ahead and add it to the AI too, because the computer gets a little confused. So let's move this guy back in there, and I'm okay with being able to move the player while game's over. It's not gonna get you any bonus points. It's not gonna do anything for you. But yeah, so there we go. The computer should stop moving, the ball should stop moving, nothing should happen. So that's good. Let's go ahead and put in some restart logic, because obviously this hopefully is a game that you enjoy playing. You're not going to play just once. So let's handle that, and let's make another if statement and say what we want to do if game over is true. And we're going to create some text now that I will say is game over text. And actually something that we didn't do at the beginning of this game that I try to do at the beginning of every game is I just try to define a font, because any text that you want to draw onto the screen in the game, you have to use Pygame's very specific method of putting text on the screen. So that starts by defining a variable I call font, or offnet, apparently, because I can't type. Fortunately, typing is not a requirement for coding. Okay, so font equals Pygame dot font, and then you can use any font you want. A lot of the times using a fun font can really change like the theme of your game. I am using a free one that comes built in with Python. Okay, and then font size is the second variable. I'll just say 20. That's kind of normal game font, but you can play around with that as much as you want. But okay, so we defined font as a variable, and now in our game over text, you have to do it in 2 steps. You have to render it, and then you have to draw it onto the screen with the blit function. So game over text is going to be equal to font.render, and then game over. So we're telling them they lost, and second variable true. We're going to make it white on a black background. Okay. And let's see, the second piece that I was talking about is screen.blit. You have to draw the text onto the screen. So what are we drawing? Game over text. And then you give it coordinates for where to draw it onto. So I'm going to do 8130. That's kind of high in the middle of the screen. And again, that's just something you can play around with. But let's see how that looks. Game over. Okay, so second thing I think we should do is add some restart text. So I will call that restart text. Make the text say press to restart. And let's put that same X. We'll probably want to scooch it back since there's more text here, but let's put it 100 lower on the screen. Let's put it 230. And we also are going to want to draw, we'll get to this after we check and make sure it looks okay. But we're also going to want to draw a rectangle. Ooh, game over. Because we're just drawing game over text in 2 places. It's important if you're going to copy paste stuff like that to actually run it like I just did and check, because you can't just assume everything you drew looks good. And like you can see here, I'm going to scoot it to the right a little bit, and I'm going to scoot it up a little bit. You can't always really envision what something's going to look like until you just run it. So okay, we also want to draw a rectangle, which I'll just call it restart button, because you can't use like a click collide event. You can't do collision with text for some reason. You need a rectangle. So I'm going to make a rectangle that is just a pygame.draw.rect, and we're going to put it right at the restart text, and we're going to just make it a black rectangle that gets drawn behind the text, but this way there will be something to check whether or not the person is clicked on. Okay, so pygame.draw.rect. And then we want to put on the screen, we want it to be black, and we want it to be at 7150. So again, we're giving it the exact same coordinates as the text, and then that block of text is probably 100 long, and let's just go ahead and say that it's 20 tall. But the idea is if you're clicking anywhere in the rectangle area that says press to restart, we can assume you want to restart because the X out of the game button is way in the top right. Okay, so we need a new event type now because this is the first time the players need to click. So we want to say if event.type is equal to Pygame, and then this is going to be mouse button down. We'll just do when you click down on it. Some people would do click up, and that's when you release the mouse click, but that, hey, user preference. So now let's do if, I think we called it restart button, and then so restart button dot collide point, and we can do a nice thing here, which is event dot position. So the click in this case has an X and Y coordinate, and that's considered the position of the event. And that is what we're checking here. And so we are saying, all right, well, they've clicked the restart button, so what do we want to do? Well, the most obvious thing is we want game over to be equal to false, because they just restarted it. But in that scenario, I actually think that what we should do is make game over equal to false to even, or true to even click, because there's no reason to be clicking on anything if game over is not true. But then you also got to think about pretty much everything we did to initialize this game. all of this stuff should come back into play, right? Like if speed changed, if direction changed, if anything changed, we want to get reset when you hit restart. So you could create a little function to do that. I'm just going to put it all under the button again, and let's go ahead and see if this is going to let us restart now. Press to restart. Okay, so that's cool. It moved, but game over. Oh, it's because it's a double equal sign. Alrighty, let's try that again. Alright, so that's pretty sweet. We just keep getting closer and closer to like a full functioning game. This is getting pretty fun. I think the next step to do will be, let's go ahead and create some score tracking. So score is obviously equal to 0 when the game starts, and score is going to also get reset to 0 when we hit the restart button. And then I think in check collisions, right, we already have a function that checks the whether or not something has collided, and that's also when we want the score to update. So this is pretty cool. We'll just kind of leech off of that function and add some score calculations onto it. And we just need to make sure where we call that function, which was, that was check game over. There was ball X direction. Yeah, okay. And then score. And then we also need to pass it in. But then we should draw that onto the screen. So let's go to where we draw our rectangles and everything. And let's steal this 2 lines where we define font and everything. And let's just call this score text, right? Score. And for the text, let's say score, colon, and then let's add string str conversion of the score. You could use an F string if you want. That's just formatting everything inside of it to be a string. That's kind of a shortcut. You can do that if you want. But if you're doing stuff like that, you know plenty about Python. You don't need to be here at all. So let's go ahead and see how that looks. Just kind of slapping it on the screen here. Score. Oh, we got 3 there, and we got 7 there. Okay, let's take a look at why that's updating by 3 or 4. If ball collides with the player, ball X direction equals 1. Why don't we say and ball X direction is equal to -1, meaning it was moving to the left, and then here we'll say and it equals +1. And this hopefully will act kind of like a one-shot, and now that code will only happen once, so that appears to be doing it. I'm guessing just like the computer is able to scan so many times that it kind of viewed like 2 or 3 different scans where the ball was still colliding with the player even though it was changing direction. So it's just a symptom of computers being very fast. Sometimes you want to build in a little extra check that will keep track of things like that. Okay, so yeah, we're getting up there in time on this video, so let's just add a few things that will make this a better game. And for the ball, I think, well, one, we don't really need this ball X direction, Y direction stuff anymore, because it's really all based on colliding with the paddles, but we're gonna leave that in there. But one thing we do want to do is this ball speed in the X and Y direction, right? We have, we just start them out as 2 and 1, but we don't do anything with them from there. And I think it would be fun if it got harder as it went up, as the game went on. So let's go ahead and do ball speed, so this is in the X direction, right? And this is going to be equal to, let's say 2, which is what it starts at, but then let's add score, and let's use this function that's called floor division. So because we're updating something in pixels and it needs to be an integer, this is always going to divide down to the lowest whole number. So this won't be a 1, it'll be a 0 until you're up to the value of 10 as your score. So this way the ball will go faster in the X direction every 10, you know, it'll go 1 faster. And then in the Y direction, let's go ahead and say that it equals to 1 because that's what we started at, right? And then every 15 it'll go 1 faster. So I'm just winging it here, but that seems like that would be a good adjuster. So let's see if I can get a decent score going here. Might actually start the ball a little bit faster just because the game is pretty easy to start, but I mean that's how games are supposed to be. So let's see if I can get up to like 15 or 30 here. A big part of me being able to display this is being able to play the game decently. But you can kind of tell when we hit 10 it got a little faster left to right, and now we are above 15 and it definitely sped up and down. We should get the next, yeah, so it just sped up again in the X direction, and here if I can get another 6 points it'll speed up in the Y direction again. And it's actually already getting pretty tricky. I'm definitely slightly better at writing code than I am at playing video games, but you can probably tell, I know the screen capture isn't exactly at 60 frames per second, so it might look a little choppy, but this game got really fast. You actually can see there I won the game. I beat the right player, so that's pretty sweet. What we had there is we just had the net speed get higher than the AI was able to move. So it's because we built a very simple AI, and so the speed that we give it in the X and Y direction is going to limit when it can finish. So if you have watched this long in this series of tutorials, you definitely deserve an Easter egg or something fun to reward you for your patience. So since now we have this fully functioning game with restart logic, you play against a computer, let's just do something fun to make this a little bit unique. It is 2021 or later. It is not 1972. And so let's just go ahead and do something kind of fun where every time the score increments, let's mess with the ball color too. So actually we don't even need to pass it in. We are just going to return another variable that I'll call ball color, and every time the score increments, let's go ahead and say ball color equals, and let's grab 3 random integers between 0 to 55. And so you will need to import the random module to do this, but now I've just said, okay, well, when the score updates, I'm just going to generate a new color with 3 random RGB values. So it could literally be anything. It could be terrible. Like if it is black on a black background, that's obviously not ideal, but those odds are pretty slim. So now let's see, we've got this ball color variable, and towards the beginning, because it does have to exist initially for us to use this, let's say the ball starts as white, and let's go ahead down to where we draw the ball equals here, and instead of it just being constantly white, let's make it equal to ball color. Alright, and that's probably gonna do it. Let's go ahead and run this and see if we get a cool color changing ball. Local variable ball color reference before assignment. Yes, of course it is, because if you're not going to pass it in as a variable, then you do need to tell them that you are referencing the global, so it has something to refer to and say, okay, this is an existing variable. Alrighty, so we've done some too many values to unpack in ball X direction score. Oh yeah, I don't think we're grabbing it back from there yet. There we go. Okay. Alrighty. So you can tell I'm getting a little tired. Okay, but the ball changed color. That was pretty sweet. Let's go ahead. I'm gonna just start out by increasing the ball's initial speed to 3 and then 2 in the Y direction. And I'll make sure I do that in the restart logic as well. But you can just tell, like, the game starts out a little too easy, which is definitely something like you can do if you want. But 3 plus 2, there we go. And let's take a look at this. Yeah, so it just starts out harder. I mean, if you're a fan of challenging games, I think this is a little more fun. You can tell that the colors are changing, and I think that's just kind of fun. It reminds me of like a loading screen. But this is pretty sweet. Like, we just built a full video game that was at one point the height of video games that people had to play, which explains why, like, in the 70s everyone wanted to nuke everyone and stuff. But I'm pretty pleased with this. I think it's super fun. One way that you could make it to where, like, the computer's quite a bit better and you're more challenged is you could just up the computer speed. You can mess with colors, you can mess with power-ups, you can mess with anything you want. This is the root code of how to do it. Hopefully you found this useful. I know this was quite a long tutorial, but this really is start to finish how to build this entire game. I had a ton of fun doing it. Hopefully you found it useful. If you did, if you're still here, thanks for watching the whole thing. If you would do me the favor of smashing that like button, subscribing to the channel, it would help me out a ton. And I really appreciate your time. I hope you had fun doing this. And if there's anything you want to see in the future, be sure to let me know about in the comments below. And I'll get back to you as soon as possible. Really appreciate your support on the channel. And as always, good luck with your code. And thanks for watching. Thanks. Bye.